Intext question 6.4. Among the isomeric alkanes of molecular formula C5H12, identify the one that on photochemical chlorination yields. First one, a single monochloride. Second one, 3 isomeric monochloride. And third one, 4 isomeric monochlorides. First of all, what is photochemical chlorination? For example, if methane reacts with chlorine in the presence of light, then chlorine breaks into chlorine-free radicals, and this chlorine-free radical will substitute one of the hydrogens of methane, forming methyl chloride or chloromethane. So this is known as photochemical chlorination, where one of the hydrogens of methane is getting substituted by chlorine, or in general hydrogen of alkane gets substituted by chlorine in the presence of light. This is known as photochemical chlorination. Now in this question it has been asked that the compound C5H12, alkane having formula C5H12, that is pentane, which of the isomers of pentane will form first one, a single monochloride? Now the answer to the first one is this compound, this isomer of pentane, that is its IUPAC name will be, this is the longest carbon-carbon chain and numbering the chain as 1, 2, 3. This is 2,2-dimethyl propane. In this isomer of pentane, the second carbon, this is the quaternary carbon, and the other carbons which are present as methyl group, all these carbons are primary carbon. The quaternary carbon, it does not have any hydrogen atom, so it will not form bond with chlorine. Whereas the 4 methyl groups which are present around this quaternary carbon, the hydrogen present in these methyl groups may get substituted by chlorine, giving a monochloride. Now here this is one of the products formed. Now if you name this product, then this is the longest chain containing the chlorine atom, numbering the chain giving the lowest locator number to the carbon bonded to chlorine. So this becomes 1, 2, 3. The product is 1-chloro-2,2-dimethyl propane. Now similarly, if this carbon gets bonded to chlorine, then again this will be the longest chain and the numbering will be done giving the lowest locator number to the carbon bonded to chlorine. So 1, 2, and this will become the third carbon. Again the carbon bonded to chlorine gets the locator number 1. Similarly for this carbon also, when it gets bonded to chlorine, it will get the locator number 1. Then this carbon also, when it bonds with chlorine, it gets the lowest locator number as 1. So only one product, one monochloride is possible with this isomer. This isomer reacts with chlorine to give a single monochloride. So this is the structure of the isomer giving a single monochloride. Now the second part, 3 isomeric monochlorides. For 3 isomeric monochlorides, you will need 3 types of carbon atom, which when bond to chlorine give 3 types of product. Now this is the primary carbon, this is the secondary carbon. Then this is also secondary carbon, this is secondary carbon, this is primary carbon. Now numbering the chain from right to left, this is 1, 2, 3, 4, 5, and numbering the chain from left to right, this will be 1, 2, 3, 4, 5. Now as can be seen, the lowest locator number for the carbon present on the right end of the chain is 1, and the lowest locator number for the carbon present on the left end of the chain is 1. So these two carbons are of the same type. So denote these carbons by the alphabet A. Now again from the right hand side of the chain, this is the second carbon, and from the left hand side of the chain, this one is also the second carbon. So these two carbons are also same. So name them as carbon B. And the third carbon, it has the same locator number, that is 3. So name this carbon as carbon C. So as can be seen, there are 3 types of carbon present in the chain. So 3 types of chlorides will be formed. When carbon number 1 is bonded to chlorine, it is 1-chloropentane because the longest carbon-carbon chain is of 5 carbon. When carbon number 2 is bonded to chlorine, then it is 2-chloropentane, and when carbon number 3 is bonded to chlorine, it is 3-chloropentane. Now the third question, 4 isomeric monochlorides. 4 isomeric monochlorides. For that 4 different types of carbon will be required. Now here in this compound, in this isomer, this is the primary carbon, this is the tertiary carbon, this is the secondary carbon, this is again the primary carbon. A methyl branch is present on this carbon chain. So the longest chain will be selected and locator number will be given to the chain so that carbon containing the methyl group gets the lowest locator number. Now if chlorine bonds to this carbon, then numbering the chain, this will be carbon number 1, this will be 2, this will be 3, this will be 4. The product will be 1-chloro-2-methyl butane. If chlorine is bonded to this carbon, that is the tertiary carbon, then the product will be 2-chloro-2-methyl butane. Again, if the chlorine is bonded to this secondary carbon, to give the lower locator number to chlorine, carbon bonded to chlorine, the chain will be numbered from left to right, that is 1, 2, 3, 4. Now the name of the compound is 2-chloro-3-methyl butane, and when chlorine is bonded to this carbon, then the name of the compound is 1-chloro-3-methyl butane. So 4 different isomeric monochlorides are formed. So if you want only a single monochloride, then you have to arrange the carbon-carbon chain in such a way that there is only one type of carbon present. So no matter to which carbon chlorine is getting bonded, the product will be the same. If you want 3 isomeric monochlorides, in that case carbon-carbon chain has to be arranged so that 3 different carbons are available, and so that 3 different products will also be formed. 3 different monochlorides will be formed. For 4 isomeric monochlorides, carbon-carbon chain has to be arranged so that 4 different carbons are available, and when chlorine bonds to these 4 different carbon atoms, it gives 4 different monochlorides. These monochlorides, they have the same molecular formula but different structures.